Hello guys, welcome to yet another video about custom chatbots for documents, right? I have created a video about Llama2 using ChromaDB, and in the previous videos in the LangChain series, I have used different vector stores, but many of you asked me to create the videos using Faiss CPU or Pinecone or all the things, right? What I'm planning to do in this video is everything is same. As you can see here in the first page, we are going to ingest the document, or we are going to take the text file, split into chunks, use the embedding API and store that into the vector store, but not only in one vector store. We'll be storing in Pinecone, Faiss CPU and ChromaDB, and we'll create three different applications using that particular vector stores, right? And let's see which one performs the better. And at the end, I will also show you how you can just plug in the OpenAI models in the existing code. And for that, I'm going to use ChromaDB as an example. By the end of this video, you will have a working repository in the Git where you can just freely use all the resources, and you will have a video where I will be explaining all the different vector stores. And I hope after this video you don't need to jump around different repositories. Everything will be in one repository and in one video. Let's get started. I am on the GitHub repository, right? So there are many ways how you can follow this. Everything is documented in the readme file, right? But what I'm going to do is, as usual, run it on the GitHub code space, right? There are many ways that you can follow. One is you can go to this plus icon and then import the repository or new code space and create a new code space. Or next thing is you can go to the code part and then go to code space and you can run the code space from here. But one thing that you need to notice is, in order to run the Llama2 models, we need minimum of 16 GB of RAM, right? For that, if you go to this code space part, the default one will not be sometimes of 16 GB. So for that, what you can do is first go and fork this repository, give a star if you like it. And then once you do that, go to this plus icon, go to this new code space. I'll open this in new tab, right? And from here, you can choose the repository. Let me choose the Llama2 different vector stores, and the main branch, the region where you are, choose the one that you are close. And then there will be the 2 cores, right? But we can go with the 4 cores, that is 16 GB of RAM and 32 GB of storage, right? If you want more than this, because it might not be even enough, then you can pay some money in GitHub code space and just use the resources, right? But for me, I have already cloned this thing and now it is running here, right? If I go here, there is this Llama2 and I can just open this in the new tab, right? So here it is. I have already opened this. And what you need to do now, right? There are different steps that you need to follow now. This is the cloning part that we don't need to do if we are in the GitHub code space. And next thing, you need to copy the example.env to env, right? Example.env contains the API keys, right? So just these are the things that we need to provide. I will show you what are the different things. But for Hugging Face and OpenAI, you can go to the different links here. This is the OpenAI link. This is the Hugging Face link. Just go there and then get the API keys. If you don't have account, create the account and then just paste it in the .env, which is just the copy of example.env, right? And then you need to create a virtual environment. And there is one thing that I have mentioned here. If you have Python 3.11, just creating with this command might work, but sometimes it doesn't work if you have Python 3.11 or lower. So for that, you need to have the Conda installed. And if you are working on GitHub code space, you don't even need to install, because if you do Conda version, there is already the Conda installed in the GitHub code space, right? You can just run this particular command specifying that you want to use Python 3.11, so that we are good to go. Now, if I do Python version, right, it will show me 3.11.4, but by default it is 3.10, meaning that I have already created the virtual environment using this particular Python 3.11. I hope that is clear now. And the next thing is you need to install the necessary packages after installing the virtual environment. Please remember that create the virtual environment before and then install the necessary packages. What are the packages? It's mentioned here. You can just run this particular command in the terminal, right? So I can just sit on. What is the next thing that you need to do is now you need to create a folder called model and then go inside the folder. I have already created the folder mkdir model from the root directory. Remember that. And root directory meaning that I am on the llama2 different vector stores. And you go inside the model, and I have already provided you the command also what to run. Just run this command in the terminal, then you are good to go. But from where did I get this URL? If you go up here, there is this Hugging Face model, right? If you click this, it is taken to the Hugging Face website. This is the model that we are going to use, the block llama2 7 billion chat.html, right? And you can just right click here and then copy link address, or you can just directly download and upload in GitHub Codespace. It's up to you. If you are using locally, you can just download this and place it inside the model folder, right? Once that is done, then we are good to go. Let's see what is the step next. It's just to run the ingest ChromaDB, right? Then we can just ingest the file and then we can run the app using Chainlit. Let's go through each and every step. And one thing that you need to remember is, although there are different things that are being used, right? Ingest, there is Chroma, Faiss, Pinecone. The syntax is different, but the process that we are going to use using LangChain is similar. Okay, so how we will proceed is first go through one vector store, right? I will go with the Chroma, and then we will run the app, and then we will be following the Faiss and the Pinecone part, right? Let's go with the ingest, right? For that, what you need to do is go inside the ingest folder, right? And if you go inside the ingest folder, there is this ingest chroma.py, right? So as I said before, the syntax is little bit different. I will explain you a little bit about Chroma, and other things will be the same, right? Here, these are all the necessary things that you need to download, right? And there is this Hugging Face API token part. We are loading that API token. We are creating the directories for DB Chroma to store the embeddings, and the data is here. For the data, I'm just going to use the state of the union txt. It is in the GitHub repo, so you don't need to download this, right? What are we going to do now? Here I have just explained all the different things that you can do because I have uncommented the code here. So you can just use this particular code if you want to use PDF files or text file or so on. I've explained this in my previous video about llama2 also. You can refer to that, right? But in this case, I'm just going to use the .txt for the demonstration purpose only. So I'm going to use the directory loader. Data directory is here. I'm just going to use all the txt files. I'm going to use the text loader, and we can just load this particular thing. And if you want to print, you can even print. I'm not going to go through here now. And now there is the text splitter part. I'm taking the chunk size 1000 and chunk overlap is 100. You can just play around with this, whichever best fits your use case, right? And then there is this chunked documents, and that is what we pass the loaded documents here. Then that is chunked. After that, we will have the Hugging Face embedding. We will take the Hugging Face embeddings, sentence transformer, all mini LM L6 V2, right? And then we'll be using the CPU. And what do we need? Now we create and persist the Chroma vector store. Persist meaning that we will store that somewhere, right? And when we run this particular ingest Chroma file, a new folder called vector store will be created. So the document is chunk documents, embedding is the embedding, right? And persist directory is the DB Chroma path, meaning that if you go up here, we have DB Chroma path, right? In this particular folder, it will be created and stored, right? And then we can just run this file. So if I go here, okay, let me just cancel this and go here. And what I can do here is just to Python 3, right? And I need to run this particular file. So what is the file name? ingest_chroma.py. Remember that I'm inside the ingest folder, right? And then I can just run enter. What it will do now is create a vector store folder. Inside that, it will create a, what is the name? DB Chroma folder, right? And then all the embeddings will be stored there. It will take some time in order to do the embedding part. So it is doing behind the scene. and now you will see the vector store folder being created here. It will take some time, let's wait. And once that is done, we can proceed to the app using the ChromaDB, right? So as you can see here, the vector store folder is being created. Inside the vector store, there is db chroma folder being created, and inside there are the embeddings, right? So now our document embedding part is done, meaning that in the diagram, until the place where we store this vector store is being done. Now the next part we need to follow, right? Which one is the folder? Okay, this one. Now I can go back, right? I can go cd ... I can go inside the app folder because I need to run from the app, just showing you step by step. So now I can go to the app folder, and there is this app chroma.py, right? So I'll just walk you through this now. Let me make this bigger. So here is just the normal importing things. Here is the normal things that before, loading the environment variables, and then db chroma path and the model path, right? We downloaded the model inside the model folder, right? So we need to provide the model also. And then there is the prompt template. You can just set the custom prompt. I have explained this in my last video also, but yeah, we just create a prompt. We created a retrieval QA chain, right? And we pass all the necessary things here. If you have watched my LangChain videos, I think you are familiar with these kind of things. We need to pass the large language model, chain type stuff, and what is the retrieval we want to use. We want to have the similarity sorts of 3 different document chunks, right? And return source, we want the source to be returned true, and we just pass the chain type arguments prompt as prompt, right? And then we load the model, right? Model path, it is mentioned here. Just go through the repository, and then what we do is we have the large language model. We use C transformer. We use the model path, model type, and then we have the max new tokens and the temperature, right? And this is all mentioned here. So as you can see here, that's all we need to do, right? Now we return the large language model, and then we have the create retrieval QA bot part, right? For that, we need to use the same embedding model that we use for ingestion part. And we have the db chroma path from where we want to take that particular embeddings, and we want to use the CPU. So we retrieve the things, question answer. We have the question, it needs to go to the part, right? As you go to the example, we have the question, we need to do the embeddings using the same embedding API, and we need to do the similarity sorts, and it goes to the vector store, find the ranked results, right? Depends how many similar documents you want from. We want 3, right? And these documents are passed into the large language model, and then we have the answer, right? So that is all what is happening here, right? Retrieval QA part is here, and then after this we have the embedding, as you can see here, and we have the load model, right? And then you can see here there is the create retrieval QA chain, and we retrieve the bot answer here. So what we want, create retrieval QA bot, and then yeah, that's all the answer. We return the bot response, and this part is just for the Chainlit application to show you, right? So here is the Chainlit app, and here is the one to process the incoming chat messages. So yeah, that's all for this. We can just Control S if you have changed something here. Now you can go here and then just run the app. So Chainlit run, and we need to provide the name of the file, right? App, and then we have chroma.py, right? And we can just pass -w. If we make any changes, it will reload automatically. That's what the -w does, right? It says that your app is available at localhost 8000. I can open it from here, or I can open from here. I can control click here, so it is going to open the app. This is similar how you open the app locally also in a local host, right? Now we have the chat, we have the readme. For some reason it takes some time to load this one because it is still provides the same thing here and here, right? When this is loading, just a good reference for you, there are some useful links in the file. If you want to get started with Chainlit, I have created a playlist, and with the LangChain also I have created a playlist. You can just go around here, and if you want to support me, here is buy me a coffee or Patreon, whatever you want to do, right? So yeah, it is taking some time still to load. Let me see if it loaded or not. Yeah, here it says, hi, welcome to chat with documents using Llama2 and LangChain, right? So we can ask the questions now related to that statement, right? So what I can ask is, what is the president saying about NATO, right? For all the different things, you can just refer to the file, state of the union file, right? This is the file which we open inside data. So you can ask as many questions as you want from here, right? So you can say Officer Mora was 27 years old, right? So you can ask the question, what is the age of Officer Mora, right? Let me ask that question actually. Let me go here and say, what is the age of Officer Mora, right? So if it provides the answer or not. Now I'm going to ask the same question for each of the vector stores and see which one provides the correct answer, right? And then at last I will ask the same question with OpenAI model also, and let's see which one gives us the best result, right? It is now going to take some time, right? It is saying here retrieval, using retrieval QA, using stuff documents chain, using LLM chain, and it is running, right? So these are all the different things we have mentioned in the app. This is the good part of Chainlit also, that you can see which is currently running and what will be the result of this. I can just go here and just remove this, and you can even go to this icon here, and in the settings you can say expand messages. It will automatically expand that, right? You can hide this, hide chain of thoughts, so it will not show you what is happening behind the scene. It will just provide you the answer, right? And the dark mode, if you want to have the dark mode or the light mode. Let's go with the light mode for now. I hope you also know how to use the UI part. So yeah, it says could not reach the server for some reason. It always says this when I was running with Llama2. It will take some time to provide the answer. So it's up to you if you want to use this kind of models in production or not. But I will show you the example using all the different things as well as with OpenAI model. So you will get the idea, and it's up to you to decide which one to use, right? But yeah, let's see. It is still taking some time. Okay, it took some time and provide the answer, but you can see that the answer is not correct, right? So the answer is, okay, what can you may I do you, all the different things, and it says sources and restore. And yeah, these are the things that is showing here, and it shows the sources. Okay, let's stop seeing each other as enemies or the different things. And yeah, Officer was 22, Rivera was 22, Officer Mora was 27 years old, meaning that it is going through the same document, right? It should provide the answer, right? As you can see here, answer is there in the source where it collected, meaning that Llama2 model was not able to provide us the answer based on the sources the ChromaDB has provided, right? Because it does not provide us the answer, but from the chunk it provides the correct answer from here, right? Because it took the right part of that from here. So yeah, that's how the ChromaDB provided, right? So now let's go and see how the answer will be compared to ChromaDB with Faiss CPU. Okay, so now I can just go to the terminal and run Ctrl+C. It is now the app is not running, right? So this is how the ChromaDB works. Now let's go to the Faiss CPU. I can close this ingest and the app Chroma. I can even close this state of the union, right? So now I can go to the ingest Faiss Pi, right? So as I said, everything is same, but some syntax is different here. So everything until here is the same. So if you go down here, the loading part is also the same, the text splitter part is also the same, right? But and the loading model part is also the same, embedding model. But here the vector database, this is also the same, right? But when you want to store it, you need to provide vector database.save local, and you need to provide the path of the files. This is just the difference. I'm not going through all this again because you get the idea. This is just the one step, right? I can go back, I can go inside ingest, and what I can do is I can just run ingest and faiss.py, right? When I run this, because we already have the vector store folder created here, and we just have the db chroma, but now what it will do is it will create a new folder called db Faiss, right? As you can see here, we have db Faiss, but the vector store, the higher level directory is the same, right? So yeah, it completed. And if you go inside vector store, there is db chroma and there is db Faiss, right? Inside db Faiss we have all the different vectors embeddings being stored, right? So now what we can do, we can go again one step back, we can go in the app, and now we need to run the app.faiss.py, right? Now I'm not going to go through all again, everything is same except the part that the syntax is different to retrieve the information, right? So how to do the retrieval part? If I scroll little bit down, still down, because everything is almost the same there, right? So here, so db, right? So here is the Faiss.load local, and the file we need to provide the path and the embeddings. Just to show you that what it was in the chroma, here is the chroma, right? Let me click it here. If I scroll little bit down, no, this is not, this is here, right? So if I go to the chroma part and if I go up here, so where is the retrieval part? So here you can see there is db chroma persist directory, and embedding function is embedding. This is how we can use or retrieve the db using chroma, but with, where is the file again? Here, app.faiss. Here it is Faiss.load local, right? Here is load local, and we need to provide the path and the embedding. But in the case of chroma, it is chroma persist directory and the embedding function. It's the same, right? But little bit different things what you need to provide. So now I can just go here in the terminal, clear the screen, and run Chainlit, right? I can say app, if I do autocomplete Faiss, I can say no cache, because I don't want to store it right now here, right? If you are creating the application, you can store it in the cache, right? I can then now run the app. It will run the app. It says it is running in the local host, right? So yeah, it is going to run here. There is the chat, readme. Hi, welcome to the chat with documents using llama2. Let me make this here. And what I can ask here now is the same question that I asked before. What is the age of Officer Mora, right? So if I go here and run enter, so what is happening now is now it is using Faiss CPU locally instead of ChromaDB. And let's see what will be the answer. As it was taking some time before, I will get back to you once this. Okay, it took some time, around the same time that it took for the ChromaDB. But it said here the above, I do my answer below the question answer. This can address the, okay, it does not provide the answer, right? And but the same thing happens here is, but in the source document, there is the answer, right? Officer Mora was 27 years old, meaning that again, the Faiss CPU vector store is working correctly. It is getting that particular chunk, right? And then that is passed to the llama2 model, but the llama2 model is not able to provide us the answer. Why? Because I think the RAM is not enough for this, because I'm just running on GitHub code space using 16 GB of RAM, right? I just want to show you how it behaves in RAM, but you can see the retrieval part is doing what it needs to do, right? So yeah, that's all for this Faiss CPU also. Now what we can do is go here to the terminal and we can just say Control C, so it cancels. I can clear this, right? Now what we will do is we will go through the Pinecone, and here it's little bit different because we are not going to store this locally, but we are going to create the index in the cloud in the Pinecone website. So this might be helpful to you. I'll walk you through each and every step to create the vector store in Pinecone website and how to retrieve out of it. Okay, now let's go through the Pinecone part, right? So we can go to the ingest pinecone.py. So it's a little bit different. As I said you before, we are going to store this in the website of Pinecone, right? So the importing things are here. We want to import the Pinecone from LangChain vector stores. We want to load the environment variables, but we need to provide this Pinecone API key and Pinecone env, right? For that, I will provide the link in the readme file as well as in the description of this video. This is the Pinecone website, right? app.pinecone.io. Here you need to create the API keys, right? So if you go to the API keys part, so here is the environment, right? Asia Southeast 1 GCP. So this is what I have provided here, right? So Pinecone env, and that is stored in the .env, as I said you before, right? And then you need to have these API keys. You can just copy it from here, right? And then you can just paste it there. This is the first step that you need to do in order to use the Pinecone API key and Pinecone env, right? And then here is data directory is data, because we want to use the same data, right? And you notice that we don't have the vector store data folder here now, because we are storing this in the cloud, right? So what we need to do here is, yeah, all the things are the same until here, right? Because we are using LangChain for that. We are using the text loader, we are loading that, we are doing the splitting part, same thing, and then we are using the Hugging Face embeddings, same thing until now, right? But what we need to do is there are different steps that you can do. You can create the index in the Pinecone website and then just retrieve the information. But what I'm doing here is creating the index already from the code, so it's easier, right? What we need to do is we need to initialize the Pinecone, right? So you need to run this code, Pinecone init API key, and the environment we just grabbed on the top here, right? We are just using this part here. And what is the next step? We need to provide the name of the index. This is the name that you need to provide, right? Llama2 LangChain. This is what I have already provided here. If you go to the indexes part, there is Llama2 LangChain. And now if you go back, here I'm saying delete index if same name already exists, right? So if index name in Pinecone list indexes, you delete that. I will show you that it will delete or not, right? Because when you are doing the prototype, you want to use different projects and you want to just override this, meaning that you can delete this and then create the new one if the same name exists, right? And then you want to create the new index, provide the same name, and this dimension you need to be careful here, because this is different for different embeddings. For these embeddings, all mini LM-L6v2, the dimension is 384. We need to provide that. And the matrix, we want to use the cosine. So you can use this in the UI of Pinecone, but it's easier with a single line of code here, right? So then that is created, and then we use the same thing now, right? So Pinecone from documents, we pass the document, we have the embeddings, and index name is what we want to pass the index name. But before, if you go to the Faiss, what we provided here is we don't provide here anything, but we want to store this locally, right? Same as in Chroma. Here if you go, we are providing the path where we want to persist that. Similar to this, for Pinecone we have to provide the index name. That's the difference. Then we run this. I will show you what happens, right? It will first delete the one it is running here, right? And then it will create the new one. Let me go to the terminal. Let me go one step back inside ingest, right? And then I can run Python 3. And what is the name? Ingest, and it is pinecone.py, right? I can run enter. When this is running, if you go to the website now, it will detect that there is this Llama2 LangChain index. It will delete this, right? I don't know if this will refresh automatically, but I will refresh here now. As you can see here, okay, it is initializing, meaning that it deleted the one that was there before, right? And then it created a new one now. So the dimensions 384, total pod is 1, and the environment is Asia Southeast 1 GCP that we provided, right? And if you click this, all the different information will be here. And now here is the vector count, how many is going to be ingested, and all the different things. I'm not going through all the details now in the Pinecone website. That would be a different video. If you want, let me know. I will create a new one. But this is how it works. And yeah, now it is being created. It took some time, and now we saw that it is being created, meaning that if we go now to the terminal, it's done, right? So the ingestion part is now completed. Now there is 43 vectors. Let me refresh this if there is many. Okay, it refreshes. Okay, so 0 vectors, it is still loading here. We have 43. So 43 vectors are being stored here, right? That's fine. And we can now go to the app part, right? What I can do now is cd dot cd app, right? I can clear the screen. I will now show you what is inside the app Pinecone. So here also, this is the importing part, normal things. We load the environment variables, Pinecone API key and Pinecone env, right? This is what we need to provide again. And we initialize the Pinecone. But now we don't need to create the index because we already have the index. We retrieve the information, right? So now we have the model path because we need to use that llama2 model. And then we provide the index because we initialize here. Then we can use the index. So we can just say pinecone.index and provide the name llama2 index LangChain. Be careful that it needs to be the same that we created in the Pinecone. That's the normal case, right? Then everything is same here. We can go to the retrieval part now, right? If you go down here in the retrieval part, where is the retrieval part? Okay, still down here, not here, here. So there is the retrieval part db pinecone.from existing index. So that is just the syntax difference. We need to provide the index name and the embeddings. It's kind of same all the different vector stores, but some syntax is different. I will just save this, right? Now we can go here and ask the question with the app, right? So for that, what we can do, by the way, the command, I haven't provided all the commands here, but as you can see here, I said chainlit run app chroma.py, and you need to repeat step 5 and 6 for different vector stores, meaning that chainlit run app Pinecone, right? So that is just the change you need to make. So it is chainlit run app, right? And that is pinecone.py, and you need to provide no cache -w, right? But if you are creating the application in the production level, you want to use the cache. So if you don't provide anything, then it will be in the cache. So now it will load. It says, okay, hi, welcome again. So you can go to this history part. What is the age of Officer Mora? If I ask the question again, the same thing is going to happen. It is going to get the information not locally, but from the Pinecone website, from the index that we created here. And then it is going to be passed into the large language model. Same process again happens. Now I hope you see this figure for many times now. I hope now it's already been clear to you, but just pause the video and just go through this if you want to know what is happening again behind the scene, right? Now if we go here, so it's still running, and let me see if the app is running. So it is still running. It will take some time. Again, I will get back to you once this is done. Okay, so now this is done. It took almost the same time that it took before, but again the answer is not correct. As you can see here, body camera use these, you don't, and something, right? But again, the thing here is the sources are again correct, and Officer Mora was 27 years old, meaning that in Pinecone also, because we are using LangChain to do the splitting, right? So whatever it is doing the same thing, and it is going into the vector store, and the retrieval part is exactly showing to the resources that we want. And there are 3 different sources, right? There is document 1 here, as you can see here. There is document 2 here, and if we scroll down here, there should be document 3. Yeah, here is the document 3, meaning that we want 3 similarity sorts, and it finds 3 similarity sorts out of that chunks, right? But the answer is not correct. Now, as a optional thing, let's go and use OpenAI's model instead of Llama2 and use the ChromaDB just for an example to see how the answer will be. Okay, now I can just cancel this now from the terminal, Control C, right? So let me clear the screen once. But now we are going to use the OpenAI, right? For that, what we can do, we can go to ingest chroma openai.py, right? So everything is same here. And there is the data chroma path. I have given different name, db chroma openai. You can even use the same embeddings that is being stored, but we are providing the db chroma openai embeddings, right? So we are loading the OpenAI API key from here, and we create the vector database. So here what we can do is, yeah, here as you can see, until this step it is the same, right? But we don't need to initialize the Hugging Face embedding now, but we are going to use the OpenAI embeddings, and everything I have passed here by default. We are using the default model provided by OpenAI, right? And yeah, other things are the same because storing into the vector store is the same. The only difference in this file is using the OpenAI embeddings instead of Hugging Face embeddings and using this particular model, right? So what we can do is go to the terminal, go to ingest folder, and then we can run Python 3, right? And then I can just give the ingest, and then I can just say what is the name, ingest chroma, and then it is openai.py, right? Once this is done, it is going to create db chroma OpenAI here. As you can see, it is created here and the embeddings are here. So that is how the embeddings are being stored, right? Now what we can do, we can go back one step here. We can go to the app, cd app, right? Let me clear the screen. So now I can go to the app, and here is the app chroma openai.py, right? I can go inside here. So here I said here it is Faiss, it is not Faiss, right? It is chroma. Typo. Okay, I can save this db chroma path, right? And here is the chroma I am using, the vector, and then there is this loading things, and all the things are the same except the modal part, right? So if you go here, retrieving information is the same, and but here instead of the Llama2 I'm using chat OpenAI, and the model is GPT 3.5 turbo, right? And by the way, you can just import here OpenAI embeddings or chat OpenAI from LangChain, because that is what the framework we are using. And then what you can do is here create retrieval QA, right? The model name is text embedding ADA002, meaning that this is the embedding model that we provided before. If I go back to here, this is the text embedding ADA002 that is being used at the embedding, and we need to pass, again, this is not the Faiss, I am using chroma, right? I can say Control S, and then what happens is everything is same here, right? And we are just using the chroma, right? And persistence directory, embedding, right? This is how we can extract the information. By the way, this is same what we used in the chroma, right? If I go to app chroma.py, here chroma persist directory, and this directory must be different in different cases because we have different folders, right? What we can do is here everything is now the same, so we just pass all the things. There is the app part and same things. What we can do now is just go here and run, not in the capital, Chainlit run, and it is app chroma openai.py. I can say no cache w, right? So when I run this, it is going to run the app locally. It will open in the terminal. Yeah, and now we are going to ask the same question. Let's see if it provides the answer or not. We can go here, what is the age of Officer Mora? We can run this, and it is going to go through the part. As you can see here, it says Officer Mora was 27 years old. That is the answer we want, and the answer is quite fast, right? And as you can see here, the source is the same. Document 1, it is there, right? There is the source. There is document 2, and there is document 3, right? Here, document 3. All the sources or the similarity sorts part and the 3 documents that we want, right? Similarity sorts are the same, but the answer now it just provided in just seconds using the OpenAI models. So why I am showing you this is because if you are running some app in the production, you can see the difference, which model you want to use. I'm not the one to tell you which one to use, but from this experiment also you know that OpenAI is performing quite better here, right? So yeah, you can just test this in your use cases and decide which model, large language models to use, either OpenAI's model, or there are other different models also, or open source models, and which vector store to use. Now I can just go back to the terminal and Control C, and the app is not running now. It says could not reach the server. That's all. Now I hope you know how to use different vector stores. with open source as well as OpenAI models, and have the conversation with your documents. And yeah, I just showed you the example of text file, but you can use PDF or whatever you want, but you need to modify some code based on that, right? So yeah, that's all for this video. It went quite long, but I hope you learned many things. Thank you for watching, and see you in the next one.